Okay, this video is on solving rational equations, and of course, rational comes from the word ratio, meaning fraction. So you see everything here is a fraction, and let's focus on the first one. Now, probably the easiest way to do this first one is to just cross multiply, but just to get you in the habit of finding a least common denominator, I'm going to go ahead and find that. So the least common denominator, you got to look at both denominators. There's a 3 on the right, there's a y plus 1 on the left, so that's my least common denominator. So what I'm going to do is I'm going to actually multiply left and right side of this equation by the quantity 3 times y plus 1. I'm going to do it there. I'm also going to do it on the right, so I'll multiply the right side by 3 times. Probably should move this over just a little bit. 3 times y plus 1. So the whole goal in math here is to get rid of these denominators. Nobody likes denominators. Okay, so on the left side you could see the y plus 1's clearly cancel out, and I'm left with a 3 and a y, that's 3y. On the right, the 3's cancel out, and I'm left with 2 times the quantity y plus 1. And now I'm back to algebra 1, easy stuff, right? 3y on the left, 2 times y, and 2 times 1 is 2 on the right. I distribute, and then finally you got to pick a side for the y's. How about we subtract 2y from both sides, and that gives, on the left it gives 1y, on the right it gives 2, and really at this point I should plug 2 back in just to make sure that it works, and I've already done it, but you know, if you have time on a test or quiz, you should always plug it back in to check for incorrect answers, or in this case, extraneous roots too, which can also happen. Just a quick reminder, in any of these videos, you should be doing them with a paper and pencil, and you can always pause or rewind or whatever you need to do. So in that sense, it's actually better than being in the classroom because you have control over the speed of these things. Okay, look at the second one, least common denominator. I kind of put that up here on the side. I have a 3 and a 5, and of course 3 and 5 both go into 15, so my LCD is going to have a 15. And if you look on the left, there's an n in both terms, so I need a 15n. So I'm going to multiply left and right by 15n. And you can see, you can rewrite the problem if there's not enough space. I'm kind of ignoring the 2 there and just multiplying both sides by 15n. Now this is a little different. You couldn't cross multiply here because you got 2 terms on the left. But if I take 15n times 2, that's 30n, and then 30n divided by 3n is just plain 10. Okay, the other way to think about it is 3 goes into 15 5 times, and 5 times 2 is 10. In the second term, 5n goes into 15n 3 times, and 3 times 4 is 12. On the right, I have 2/3 of 15n, and 2/3 of 15n is 10n. Really, I took 3 into 15 5 times, and 5 times 2 gave me 10. And again, you could see that, what was a horrible equation looks so much easier right now. So if I add this up, 10 and 12 gives 22. And if I divide both sides by 10, right, I got n is equal to 22 tenths, which reduces to 11 fifths. 11 fifths. And again, plug that back in. I'm not going to waste the time here in the video, but plug that back in. I did check it. It does work, 11 fifths. Or if you're a decimal person, I guess that would be 2.2. Okay, on to number 3. If you look here, again, you got to look in those denominators for least common denominator. And on the left, I got x minus 2. On the right, I have 1. There is no denominator, so it's just x minus 2. And so that's what I'm multiplying left and right by. On the left by x minus 2, on the right by x minus 2. And I lose all the denominators on my left. They just cancel out. Right? The x minus 2's cancel, I get x. In the second term, the x minus 2's cancel, I get 4. On the right side, I just got a distributive property. There is no denominator, so I got 10x minus 20. And then we just pick a side for the x's. All right, I would subtract x from both sides. And that would give 4 equals 9x minus 20. And I suppose we should add 20 to both sides, shouldn't we? Add 20 here, add 20 there. Right, cancel it out. 9x is 24. And here, again, not going to get a whole number, but that's okay. If I divide by 9, x is going to end up being 24 over 9. They're both divisible by 3, so that reduces to 8/3. Plug it in. Make sure it works. It does. Finally, we'll try one more here, and I'm going to be honest, this one's a trickier problem. Here, I'll put 3 stars up here just to show you what's going on. The first reason it's tricky is these denominators here are factorable. So we have to get everything in factored form first. So 2x plus 2 has a common factor of 2. You got to factor it out. Factoring as you move on in math just becomes more and more important. So I have to rewrite the whole thing. Seems like a lot of wasted time, but it really isn't. You need to get everything in factored form before you do any of this. And then the least common denominator becomes kind of obvious. You need a 2, and you need an x plus 1 to get rid of all 3 of these denominators. So that's what I'm going to multiply left and right by. I'm going to multiply by 2 times the quantity x plus 1, both on the right and on the left. And on the left side, you can see all the denominators are going to cancel right out. So all I get is the numerator. On the right, the x plus 1s cancel, and I'll get 2 times 2x minus 3. And we're back to Algebra 1. We're back to a linear equation where we collect our like terms on the left, we distribute on the right, and then what's the deal here? We got to get x's to one side, probably best to subtract 2x. And just to save a step, we got to get rid of that minus 6, so we'll add 6 to both sides just to get the x's to one side and the constants to another. So on the right side, we got 2x. On the left, negative 8 and 6 is negative 2. If you divide by 2, we get x equals negative 1. And at this point, you think, great, I'm done. Bad news. We got to plug it back in. If you look back here to the original equation, I'm just going to point something out. Right here, the denominator is an x plus 1. If I plug in negative 1, I'm going to have a 0 down here. The denominator is going to be 0. And what happens when we divide by 0? Well, the calculator crashes. We get an undefined. So guess what we got here? After all that work, negative 1 doesn't work, right? We end up with no solution. So you could state that as the empty set. Some people write this. You could write the words no solution. I think we'll take whatever you have. By the way, this is called an extraneous solution. Shows up a couple times in math. I think you're used to it from radical equations. Every now and then it shows up in rational equations. So that's it. That's why that was tricky. You know, you do all that work and then the answer you get doesn't even work when you plug it back in. Also shows you why you got to plug your work back in. So to recap, you got to have everything factored. You got to find your least common denominator. Multiply everything by the LCD to get rid of your fractions, and then should be a pretty easy problem to solve. And finally, you got to plug back in. So there's a lot of steps